All right, good morning, everybody. So, I apparently forgot that there's no class tomorrow. It's a faculty work day. I guess I knew this before because I did not list office hours for tomorrow when I set up my office hours a month ago, but it slipped my mind. So, no class tomorrow, okay? That's 224 and 215, and I'll post an announcement to 215 this afternoon to remind people about that. So that changes the order in which I want to do things today. We'll come back to VI next week, but I want to spend today talking about the current ODP, talking about your next programming assignment, Homework 4, which is posted on Canvas now, but most critically, talking about any questions you have on finishing up Homework 3. Any details, algorithms, bash, anything like that. So let's start with that. Any questions on Homework 3? Let's take care of them. Let's take care of them here and now. So, um, I'm gonna kill these lights. And when I invite people to ask questions about the homework, you don't need to judge and say, well, I know we already went over this, so I'm not going to ask the question. Ask the question now. Okay, how do we pass variables from one bash script to another? Awesome. So let's do this. So let's go into a work directory. Let's make a main script. And let's say enter a number. And we'll read that number. And then let's write a script which prints out twice that number. Okay, so I'll make something called print twice. And I'm just going to pass that argument on the same line that I invoke the name of the function. So when I say print twice, that's trying to run either a function or a script named print twice. And I'm passing it one argument, which will be the value of num. And then I'll just say goodbye from the main program. All right, so let's write a print twice function. So we'll put our shebang on the top. So take one argument and print twice its value. Okay, the argument that we pass to a script is available in $1. The second argument is in $2. So let's just say arg equals $1, and let's just echo $paren arg times 2. And I'll put some debug messages in here. I'll say I'm inside the print twice script. And then after I print that out, I'll say leaving print twice script. All right, I'll make them all runnable. And then I'll go ahead and run main. It says enter a number, I'll put in 5. Gets inside the print twice script, prints out the 10, leaves, and then the main program takes over again and it says goodbye. So what we're doing here is exactly what we might do from the command line. If we wanted to run our script, we could say print twice, 17, and it says 34, says it's inside, prints the number or leaves. So writing a separate script, right, is in some ways the easiest, but it's a little tricky passing values back to the caller. Now, if you do this in a function, you can use global variables in your script and have your function just set the value. If you want to get a value back to to the thing that called you, probably the easiest way to do it is to use a return value. So, and let me see if I can do that. I don't remember what I called it. Alright, so here's our main program. Here's our print twice. So instead of printing, let's do the following. Let's exit with that value $sign twice. And then in here, let's call print twice, pass it that argument, and let's save $sign question mark as the result. I don't know for sure if this is going to work. Let's try that. So enter a number 7, back in main, result equals 14. So what did we do? Our main program is calling this script, print twice. And when print twice exits, if it exits with a particular value, that value is available to us in this variable $sign question mark. $sign question mark is the exit status of the previous command. So that's always available to us to tell us usually if a previous command succeeded or not. But in this case, the previous command, print twice, is explicitly returning a number back to the caller by passing it through the exit function. So this script exits with a exit code of, you know, whatever our magic answer is, and our main program prints that up. The other way you can pass values back is by using back quotes, but that's going to work best if your function that you're calling doesn't generate any output. Okay, if it generates output to standard error, that's fine. If it generates output to standard out, then we've got to do something fancier. And then you're best off just using functions and global variables. Let's see, somebody says there are no stupid questions, otherwise I'd never learn anything. This is absolutely true. Right? We're here because we don't know, you know, everything there is to know about Bash programming, about C programming, or you know that and you just need the degree. But you know, chances are we're here to learn. So how do you learn? You learn by finding where the walls are that you have to beat your head against, and then beating your head against them, right? So yeah, questions are the key. So let's see, I think the issue I'm having involves the mod function for the CPU. I can get the game to run if the user is selected, but when the CPU goes first, I get stuck in an infinite loop. So I posted some pseudocode on Canvas just a little while ago in an announcement. So let me take a look at that. All right, so this is similar to the code that we went through a few days ago, but let's look in particular at the main loop. So you know, greet the user, ask how many sticks, ask who goes first, show the initial pile of sticks, and so on. Okay, to get the thing started, and you can do this a number of ways. To get the thing started, let's put an if statement and see if the CPU is going first. And if the CPU is supposed to go first, just take a CPU turn right up in the beginning. Okay? Find the number of sticks, mod 5, subtract from the pile, show the pile, see if the game's over, all of that stuff. Now go into a main loop which does two things. User turn, CPU turn. User, CPU, user, CPU. Just keep doing that. Okay? One of two things will have happened. If the CPU wanted to go first, this works perfectly. Because the CPU wants to go first, well, we gave the CPU a turn right here. And then the user took a turn, and then the CPU, and then the user, and so on. right? So CPU, user, CPU, user, CPU, everything will work out great. If the user wanted to go first, we'll simply skip this statement. And in the beginning of the game, the user will go first, then the CPU, user, CPU, user, CPU. And you can code this as an infinite loop. You just need a way to get out of it, right? So I put little footnotes here next to each one. Part of the footnotes is, you know, check to see if the game is over, and if it is, then exit. All right. Now, if you're in a function, you can say exit. If you're inline code, you can say exit. If you're in another script, it's hard to get the script that called you to exit unless you pass a value back to it. So you can pass back 0 to say keep playing. You can do an exit 1 to say the game is over. And then in your main program, when you call that script, check $? After. If it's not equal to 0, exit. So there's different ways to wire this up. Right, but this will be a main loop that, you know, generally we're going to code this as an infinite loop. And we're going to rely on the logic inside these two steps to kick us out of the loop. Your other option is to do a loop while some variable is, say, equal to 1. And then when you want the game to end, just set that variable equal to 0. Just make sure if you do that, if the user turn says the game should end, don't give the CPU another turn. Right, so use a continue statement or put some more if logic in here to stop the CPU from taking a turn. Someone said error level ? I'm not sure what that refers to, so maybe you can post more on that. I found that if I created a function for user turn as a separate function for CPU turn, and then called user turn at the end of my CPU's turn and the user turn at the end of my CPU's turn, it worked like a charm. That can work, but be careful with that. When you call a function, you're actually doing a call. It's not like a goto. It's actually a call, and it's a recursive call. It will work for this game because this game's only going to go, you know, a small number of turns. But if I tried to play with a billion sticks, that would blow up eventually. Okay, because if I'm inside CPU turn and I make a call to user turn, I'm nesting my calls and I'm using up stack space, and that will eventually blow up. I'm not going to check it with a billion sticks, so. But think about, especially for the next assignment, which is a C version of this game, think about how to do that without having to do these recursive calls. Okay, we will get to recursion in CSE222, and we'll be doing a lot of it. So hold that thought. You can have a game exit if the person cheats 3 times, 2 times actually. But yeah, so same thing in here. When you ask for the number of sticks to take, error check and re-ask and so on. That also includes the possibility of they put in an invalid answer twice in a row, so you want to exit. All right. So there's different cases where, you know, during a user turn you might want to exit. During a CPU turn, the CPU is presumably not going to cheat, so the only time you exit there is if you run out of sticks. How do you set a variable to another variable? Generally, yeah, what someone said, variable equals new variable, but, you know, read num, so I can put in 23. If I say x equals num, and I look at the value of x, it's num. If I want to set it equal to the value of num, I say x equals $num. And now if I look at the value of x, it's 23. So that's our usual, yeah, what someone just said in chat, variable equals $new variable. So that'll assign the value of one variable to another. And if you want to do arithmetic, right, $paren, put an expression in there. So I can say x equals $paren, num plus 1, and now x is 24. And inside this notation, $paren, you can put $signs in front of your num. You can leave them off. It's optional. This looks more like, you know, kind of a high-level language that just does arithmetic the way you expect. This is also forgiving about spacing and so on. So it's better behaved than kind of the really super picky bash that we encounter in other cases. All right, good. All really good questions. Keep going. Other questions? All right, let's talk about the next assignment. So this is not due until a week from tomorrow, okay? It's due on Friday, a week from tomorrow, but we don't have class tomorrow, so I'm posting it today. Yeah, Canvas is going to be weird, so I'm just going to bring this up. All right, so homework 4, let's see, how do you assess the next ODP again? Is it the same? I'm going to go through the ODP right after this. So homework 4, a stick picking game. You may have heard of this game before. Basically the same thing as you just are doing in homework 3 and finishing up tomorrow, but written in C instead of bash. Okay, so the algorithm's going to be basically the same. There's a few differences here from how the game was originally spec'd out, and I want you to pay attention to those, but basically the same behavior but written in C. Alright, so following differences from homework 3. 1, it's got to be written in C. Okay. 2, the user always goes first, so don't ask who should go first, just make the user go first. This simplifies your logic a little bit. Okay. 3, the user can be really badly behaved. When you ask them how many sticks they want, they might not put in an integer. They might hit an enter. They might put an integer with a space in the beginning. Okay, you've got to be prepared to handle whatever they might put in. And we're going to go over the details of how to do that. All right, and if you catch these details, you're not going to have to worry about this. Okay, so we'll go over what you need to know, which is going to be fgets and sscanf, to manage all of the weirdness about inputs. Okay, we're going to do that today. So they might put in weird answers. To start the game, there's 2 ways that you can specify how many sticks you want to play with. Okay, so one possibility is the person will just say stick, and they'll hit enter, and you're going to ask them how many sticks to play with. Same as for homework 3. But the other option is they can say stick, and they can put the number of sticks they want on the command line. Okay, and you need to notice that 45 and not ask them how many sticks they want to play with, but know they want to play with 45 sticks. Alright, so this is a more sophisticated way to run the program. 2 possibilities. Either just say the name of the program, enter, and then ask them how many sticks, just like homework 3. Or, if they put an argument on the command line, use that 45 or 450 or whatever as the number of sticks they want to play with. Okay, command line arguments we'll get to on Monday. So my advice would be over the weekend, don't worry about this option. Just code it up to read from user input while the program's running. And then Monday we'll talk about argc, argv. If you're not familiar with those, if you are, you already know how to make this work. Alright, so determine how many sticks to start with. The game accepts either a command line argument, that's the one you put next to the word stick, or a program runtime input. That's when the program is running and it says, how many sticks would you like to play with? And the person types in a number and hits enter. We did not already talk about command line arguments for C. Right, exactly. But we have in bash. C, it's a little harder. Alright. If the person decides to use a command line argument, if they say stick space and they type anything after that other than spaces, they have got to type exactly 1 word, and it's got to be a legal integer. Okay? It's got to be an integer. It's got to be bigger than or equal to 10. If they type in 2 words on the command line, if they say stick 10 space 12, that's an error. Print out an error and exit. However, they specify the number of sticks, either on the command line or while they're running the program. If they put in an illegal entry, print a message, game is over. Okay? They get exactly 1 shot at specifying the number of sticks, either on the command line or while the program is running. Okay? None of this is hard, it's just very specific. Okay, I'm looking for you to code Very specific behavior here. And like I say, Monday we'll talk about command line arguments, and we'll go through examples of this and see. For now, just worry about, run the program with the command stick, ask how many sticks they want, get a number from them. If their number is not a legal entry, print an error message and exit. Okay, what's an illegal entry? If they just hit enter, that's not an integer. Exit, right? If they put in a number that's negative, if they put in something that's not a number, if they say haha, those are illegal entries, put an error and exit. Okay, once the game is rolling, right, you've got the number of sticks, the user gets to go first, then the CPU, then the user, then the CPU, and so on. This should be a 4, not a 3. I'm going to have to fix that. They get to choose between 1 and 4 sticks. Okay, so ask them how many sticks they want. Make sure they put in a legal integer between 1 and 4. Okay, if they put in an illegal entry, ask them again, and don't give up on them. Okay, this is another difference from homework 3. Keep asking how many sticks they want until they put in a legal number between 1 and 4. Alright, you gotta use fgets and sscanf. This is the other thing we're going to go over today, is using these two functions to input and parse an integer. Don't use A to I, don't check to see if they typed quote 3 or something like that. Okay, they might enter something with spaces in the beginning, they might enter zeros in the beginning of it. Anything that's a legal number, you should accept. Okay, the one exception to this is if they say something like 3 and they put extra input on that line after a space, that's acceptable. Okay, I'm going to let you accept that because that's going to make your code a lot easier. Okay, and again, we're going to use fgets and sscanf, and it will pick this up and tell you the person said 3. That's fine. Okay, you can take that as legal. All right, put your code in GitLab, call it HW004, all uppercase, add me as a reporter, make sure that's pushed over by the deadline, which is 8 a.m. a week from tomorrow. All right, I'll fix this 3 to be a 4. So same gameplay as homework 3. All right, questions about that? All right, let me fix my window over here. Hold on one sec. All right, chat question. Are our assignments boom or bust? You either get 100 or 0. Absolutely not. So I'll be grading your homeworks by hand. I will try to give you as much credit as possible. So if your code is close, you'll get something close to 100%. If your code is not available for download at 8 a.m. tomorrow, you'll get a 0%. Okay? If your code's perfect or really close to perfect, you'll get 100%. But there's a lot of wiggle room in there, right? So put in lots of comments. Let me know what you're trying to do. You can put a README in there, right? You can put notes in a README file, or, preferably in comments in the script itself, and say, I've got everything working except this, and here's what I was trying to do, and it didn't quite work, but if I had more time, here's what I think would fix it, right? So let me know where you are with it, right? And I'll give you as much credit as I can. Someone said, what is count? Oh yeah, there's my I lost my camera again. Okay. So countdown timer is just a little progress bar that that I can use to see how much time I have left in the lecture. So I just kind of put that up here, and I can see roughly how much time is left. It's a bash script with some Java underneath. All right, other questions. What if our code works but is messy? I'm not taking off points for style on this homework, okay? But if all of your code is left justified and there's no comments and nothing is indented, I'm going to talk to you about it in the comments, right? And I'll give you feedback in Canvas, and I'll say something like, you know, start indenting your code, you know, come up with a way to document what you're doing, so on and so forth. I won't take off points for it this time, okay? But I do want comments in your code. I want that comment block at the top with your name, the assignment description of what the script does, and so on and so forth. But for the first big programming assignment, which is homework 3, I won't ding you for that, okay? But I will mention it in the comments. All right, other questions? All right, let's take a look at ODP 410. Man, I keep doing that. That's okay. All right, ODP 410. You're writing a C function named pick. Same setup as with ODP 410A, where you wrote a C function named inc. Here you're making a function called pick. Takes an integer, returns an integer. Okay. The value it returns depends on the value that you pass to it. So if you pass an integer, let's call it n, you're going to return either n mod 5 or 1. Okay. If n mod 5 is not 0, return n mod 5. If it is 0, return 1. Okay. So this is your function that, you know, decides how many sticks the CPU should take when it's playing the stick picking game. So call pick, right? If you pass a 3, return a 3. If you pass 13, return 13. If you pass 14, return 14. If you pass 15, don't return 0, return a 1. Okay? You can assume that the argument is a positive integer, so it'll be bigger than 0. And just return, you know, n% 5. If that's non-zero, if it is 0, return 1. Okay, so similar to something you've done in Bash, but this is going to be in C. All right, again, make your own function to test this. Call pick with different numbers, print out the return value, convince yourself it works, and then link it into the test bed. Here's how you link it. So gcc-o pick, here's your pick.c, here's the test bed, and then assess pick, pick.c. All right, questions on that? All right, let's talk about getting input from the user while a C program is running. So we're not talking about command lines. We're talking about you run a program, you hit enter after typing in the program name, the code starts executing, and while it's running, you want to get some information from the user. And we're interested mainly in getting an integer, okay, because that's what we're doing in homework 4. We want to know how many sticks they want to take, or maybe how many sticks they want to play with. So you've probably learned ways to do this using scanf and things like that. Scanf is not a good way to get input. Okay, scanf, if you allow the user to be badly behaved, can cause your program to hang really easily. So you're going to hear this again and again in this course. What I'm going to suggest is when you want to get a number from the user, let's break that task into two pieces. The first piece is getting the actual input from the user. The second piece is parsing or interpreting that input. Okay, getting input is just give me your characters, right? Tell me what you want to say. You open up the floor to the user, they type something in and hit enter, and you ingest what they have typed. And you store it in memory somewhere. Okay, that's the input piece. And if you do that without concern for what they're typing, if you just try to take their input and save it in memory, now you've got a copy of their input. And you can analyze it 500 different ways, right? So after you've done the input, you're going to do the parsing of the input, the processing or interpreting of the input. All right, we're going to do the input using fgets, and we're usually going to do parsing using sscanf. The problem with scanf, just one S, plain old scanf, it does both of these in one function call. And that gives you exactly one chance to process the user's input. If you call scanf and you get some input and you try to parse it, it's not what you were expecting, you can't go back and look at that input again, because scanf is already consuming it. So we're always going to do input in these two steps. Ingest the input, parse the input. Okay, we do the ingest with fgets, we do the parsing with sscanf. And we don't want to use A to I, because A to I doesn't tell you if there's an error in the input. A to I is a really quick and dirty function you can use to convert a string to an integer if you know that that string represents a valid integer. But if it doesn't, A to I doesn't tell you that. It just gives you back a 0. Alright, so fgets, sscanf. So let's dig into these. Alright, so I'm going to make a character array. So car buffer bracket 120. Alright, car says I'm defining a variable which is of type character. Buffer is the name of my variable, but the bracket 120 says this is actually an array of characters. And it's an array of 120 characters. Alright, so character buffer bracket 120, that's defining a chunk of memory that will hold 120 characters. This does not put a value into those 120 locations. It just sets aside 120 spots in memory for storing characters. Okay, let's ask the user to specify some input. So I'm going to use a print statement. I'm going to say please enter a number. I'm not putting a new line in here, so this will print out please enter a number colon, and it'll just sit there blinking at the user waiting for them to type something in. So I'm going to say fgets, the name of the character array into which I want to read their input, the length of the character array, and then something called standard in. And for now, this is always going to be stdin. This is always going to be the length of the character array. This will be the name of the character array. So we'll read up to 120 characters from standard in. We can just think of standard in as being the keyboard. Okay, that'll change over time. And we're going to take whatever they type and we're going to store it in this memory area called buffer. So let's see what the user typed. So let's just do a print message here, user input equals. I'm going to put this inside angle brackets so we can see the start and end of this. So I'm going to say user input equals, and the %s says you can expect to see the name of a character array after the comma, and I want you to take that and interpret it as a string, as a bunch of ASCII characters, and instead of printing out % followed by s, print out the characters in this buffer up to the end of the string. And we'll drill into this later, but basically remember the end of the string is where there's a null terminator. It's something that's created by fgets. After you hit an enter, it'll put a null terminator at the end. It's a special character so that printf knows this is where the string ends. Alright, so this is, yeah, null terminator is just \0, that's right. So it's ASCII code 0. Alright, so this is our first piece of test code. Alright, and let me open up another window. And let's run this here. Alright, so I made a typo. Alright, so let's run this. So please enter a number, I'll say 23. And it says user input equals, and everything between this angle bracket and that angle bracket is presumably the stuff in this variable buffer. Well, there's the 2, there's the 3, and apparently there's a new line. Okay, that's good to know. fgets includes a new line which came in when I hit the enter key. Alright, let's run this again. I can say hello Nick, and user input is hello space Nick, again followed by a new line. If I just hit an enter key without typing in anything at all, user input is still one character, which is a new line character. If I type a bunch of spaces with nothing else, user input is, well, I don't see those spaces, but they are in there. But there's no way to tell, right? But if I type in a bunch of spaces followed by a 23, right, we can clearly see those leading spaces are part of what got stored in memory. So this is very literal, okay? This fgets is really just going to take whatever I type up to and including the enter key, which is a new line, and it's going to store that in buffer. All right, so let's interpret that input. As an integer. All right, so let's put an integer up here. I'll just do integer I because that's our favorite integer. So to convert from a character array to an integer, we use sscanf. And it looks exactly like scanf, except the first argument is the buffer in memory, the characters that we've stored in memory. In this case, this variable named buffer. And I'm going to say %d to say I want to convert this thing. I want to treat this input as an integer. And I want to save it in variable I. And remember, we always need this ampersand here because we'll talk about it later. Because C is passed by value. All right, so what's going on here? Look at the characters inside buffer. Treat these as an integer. And let's save the integer value in this variable called I. Okay, the name of the memory the memory location where we want to read the characters from, that's what buffer is. Okay, that's what we use for fgets. That's what we printed out here. The fact that we want to treat this as an integer, that's what the %d says. Okay, %d, just like when you print. And we want to save the integer value in a variable named I. That's what the %I is. Okay, the ampersand is super critical. So let's look at the result. Let's print out the value of I using a %d. Alright, so let's compile this. Let's run it. Let's put in a number. We'll put in the number 45. The converted value is 45. Okay? And this is much more profound than this. User input equals, we printed that value out as a string, %s. Right? Here, we're actually treating this thing as an integer. We've actually taken the 4 and the 5 that I typed in and turned it into a plain old integer, which I can do arithmetic on. I can, set other integers equal to it, and so on and so forth. So this is, an integer you could use in your stick picking game. You could take modulo 5 and so on and so forth. Alright, and I can put in negative numbers, and that works fine. If I say ha ha ha, my converted value is 0. Well, ha 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 is not the same thing as 0. And if I just hit an enter, the converted value is 0. And if I type weird stuff, the converted value is 0. And if I type a 0, the converted value is 0. So how do I know if the person typed a 0 or if they typed ha ha ha? So I can't just look at the return value and say, oh, I is 0, you made a bad entry, you made a mistake. Right? We need to know, did the person enter a valid integer or not? Alright, so let's check the success of the scanf conversion. sscanf returns an integer. So I'm going to take the return value from sscanf and put that in an integer called result. Alright, so I've changed my print statement. I'm going to print out the converted value is %d and result equals %d, and I'm going to print out two things. The value of I, which should be, the converted value of our input. And I'm also going to print out the value of result, which was the number that sscanf returned as the function value. So let's compile that. And so if I put in the number 5, it says the converted value is 5 and result equals 1. If I say ha ha, the converted value is 0 and result equals 0. If I hit just an empty enter, the converted value is 0 and result is -1. So this result, this value that comes back from sscanf, is really, really critical. This is how we know whether or not this variable I is meaningful to us. Alright, sscanf tries to convert a string to an integer when we run it like this. The return value result tells us if it succeeded. And if it succeeded, then the value of that integer will be an I. Okay, 3 really powerful things there. sscanf tries to do the conversion. Result tells us if it succeeded, and if it succeeded, the value will be in I. You gotta know all 3 of those things. Okay, clearly we're doing sscanf to do the conversion, but we can't just go ahead and use the value of I. It might or might not be meaningful. Before we can use I, we have to check the value of result. Okay, for this sscanf statement, the only time that we know that the conversion succeeded is if result equals 1. So if we run this and result is equal to 1, we're good to go. If we run this and result is anything other than 1, you've got an error. Right? Result's not 1, we've got an error. Result is not 1, we've got an error. Result is not 1, we've got an error. So when you use sscanf, what's the first thing you want to do? Check the result. If it's not 1, you've got an error. Okay, I can't say it any more plainly than that. But if result is equal to 1, now you can check the value of I, and that's the value that the person typed in. Alright, so this is junk code. I'll post this on Canvas, on the Linux server under the Canvas link. It's an example of using fgets and sscanf together. Okay, so let me put a final comment on here. So if result equals 1, then I is the value entered. If result is not 1, the user did not enter a valid integer. And you got to check result equals 1 or result is not equal to 1. Don't check to see if the result is equal to 0, because it could be 0, could be -1, could be 1. Alright, and this is a very specific use of sscanf. In general, if we wanted to read 2 integers and we did %d%d, result would have to be equal to 2. So look at the manual page for sscanf and it'll tell you it returns the number of things that it converted. So if my conversion string for sscanf says I want an integer, I want a double precision floating point, and I want another 2 integers, 4 things total, I would want to know that the return value result was equal to 4. If it's not equal to 4, it did not convert all 4 things. Alright, that's a really fast run through of fgets and sscanf, but that's enough to get you through 90% of homework 4 over the weekend. Alright, and then Monday we'll go through this in more detail, we'll go through more special cases, look at other ways to use sscanf, and we'll also talk about command line arguments. Alright, any last questions on any of this? Alright, cool. Enjoy the rest of the day. Have a good weekend. I will see you on Monday. Don't forget to submit your GitLab repos before 8 a.m. tomorrow. Alright, thanks. Have a good one.